squid talk to each other. So it's cool.
So when I was a kid, if you had asked me what superpower I want most in the world, I definitely would have always said the ability to talk to animals. So I grew up a huge animal lover, and so when I went to college, I obviously just wanted to study animal behavior. And as I started studying animal behavior, I started finding out that it was actually possible for me to learn how to talk to animals. Now, learning how to speak with my dog in perfect English was just never going to happen. It's silly and childish to think that an animal is going to learn our language. But if I took the time to learn how to communicate with another animal in their language, I could actually learn a lot about the animal itself. You can learn, is an animal social? Does it hunt? Is it hunted? Is it active during the day or at night? What senses are really important to them? It's a really useful tool. But in order for us to be able to use this tool, we first have to be able to learn how the animal is communicating. And to do that, we have to be able to observe them behaving naturally. And this is a lot harder than it might sound at first. No animals really enjoy being stared at by a bunch of humans. I can kind of relate to them right now. It's really hard to get a non-invasive look at what an animal is doing. And this is even harder if an animal is, say, 400 meters below the surface of the ocean. So I'm really interested in the Humboldt squid because I think that they're a fascinating animal. They're actually really social. They're always found in groups, and there's even some evidence that they hunt cooperatively. But at the same time, they're also really cannibalistic. So for Humboldt squid, 30% of their diet can be made up of other squids during times of food scarcity. So you've got this really weird situation where you've got an animal that's really social, maybe even hunting together, and yet at the same time they're constantly worried about being eaten by their neighbor. So, do they have a sophisticated way of communicating with each other to decide whether they're going to hunt, who's going to get eaten, who doesn't get eaten, or is it all just instinctual? So that's what I want to know, but in order to find that out, first I want to take a step back and talk about what we already do know about squid. For example, how might they talk to each other? So squid, like other cephalopods, their skin is just covered with these tiny organs called chromatophores. And this diagram looks really confusing, I know, but just the important thing that you need to take away from this is that an individual chromatophore is made of this little pigment granules that are contained in this elastic sac that's surrounded by these muscle fibers. And when the brain sends a signal through the nerves to the muscle fibers, they contract. And when they do that, they stretch open this pigment sac, and then the color becomes visible. And when the muscle fibers relax, the pigment sac shrinks down, and you can't see the color anymore. So cephalopods are able to use these chromatophores like pixels on a screen to create a bunch of different body patterns on their skin. Different species have different colors. Some have multiple colors of chromatophores layered throughout their skin. But Humboldt squid only have red chromatophores, which means they have two color options of either red or white. Now, we know from studies on coastal squid that these animals tend to use these color changes for both camouflage by blending in with the seafloor or other parts of the substrate, and also for communication with each other in things like mating displays and aggression. But while the coastal squid, the chromatophore displays have been pretty well studied, we know almost nothing about open ocean squid, like the Humboldts, and that's because compared to coastal squid, pelagic squid are a lot more difficult to study. For one thing, we have the difficulty of getting to them. Like I said, during the day, Humboldt squid tend to spend their time around 400 meters depth, which not only is really hard for us to get to because of the pressure and everything, but it's also really dark down there. So how do we even see anything? They do come up to the surface, but it's usually at night. So now it's a little easier for us to get to them. We can have scuba divers go down, but it's still really dark. So we either have scuba divers, which really attract the attention of Humboldt squid. They're really curious animals. They've been known to approach divers. And then we've still got divers with artificial lights, which also attract the attention of squid because a lot of their prey actually produce light. So that's kind of, disrupting their behavior. And we could try to get down to them where they're really deep during the day using ROVs, but those are really noisy. And so they're going to create a lot of disturbance in the water around them. And again, they use artificial lights. So we're still really disrupting their behavior. So if I want to learn how these squid talk to each other, what do I do? Well, I decide to use the squid as my cameraman. So by deploying National Geographic's animal-born video package CritterCam, we can get a minimally invasive look at what these squid are doing in their natural environment. So what we do is, first I figure out how this works. Or not, I'll just talk to you about it. So we have a synthetic sleeve that we can slide over the squid's body from the fins, and then we attach the camera to a platform on this sleeve. So the squid can then swim freely around for a couple of hours, at which point the camera automatically detaches and floats up to the surface, and we can recover it and download the video and other data. And the best part about this is that we're using a really low light video camera, so we don't have to use these artificial lights that can be so disruptive. And the view from the camera is really great because we can see not only other squid interacting in the surrounding water column, but we also get a really nice view of the head and the arm region of the camera-bearing squid. So we can see how some of their chromatophore patterns are changing over the period of multiple different interactions, as well as seeing the chromatophore patterns during interactions with animals in the surrounding water column. So this is really great because as long as the neighbors can get over the fact that this squid has a really weird backpack on, we can get a pretty minimally invasive look. And so we were able to do this with 2 different squid in the Gulf of California. So now that we get to see what these squid are doing, well, what did it look like? Well, most of the time, the video looked like this. So unfortunately, even with our low light video camera, the squid still spend a lot of time in waters that are just too dark for us to be able to see. But we did get lucky, and the squid did end up spending some time between around 70 and 40 meters where there was enough light for our camera to be able to resolve. And when it did, the image started to look more like this. So here you can see this sort of subtle chromatophore activity happening on the camera-bearing squid's head and arms. It's sort of this wave-like pattern of color traveling across the skin, a little rippling. We call this flickering. And we think that this is probably a form of camouflage, because as a pelagic squid, there's no sea floor for them to blend in with. There's nothing in their environment that they can really conceal themselves against. And so we think that they're using this flickering to sort of blend in with the light diffracting in the water column. And we saw this behavior whenever there weren't any other squid, or whenever we had enough light to see it, and whenever another behavior wasn't happening. So what else did we see? Well, things got a little more exciting when the squid started interacting with each other. So what you're seeing here is a chromatophore display that we call flashing, and it's characterized by a full body color change from red to white and back and forth really quickly. And it's a very eye-catching display. And we only observed this when there were other squid around, particularly when the squid were interacting with each other. And so we determined that this is probably a form of communication between the squid. So, my first thought was like, well, great, now we know how to talk to squid. It's either let's go down there and start chatting with them about what life is like in the open ocean. Well, unfortunately, we still have a lot of questions to answer about this. We know how they're probably talking to each other with the flashing, and yet we still don't know what part of this behavior is carrying the signal. Is it the time between the flashes? Is it the variation in the time between the flashes? Is it the phase relationship of their flashing with another squid's flashing? Is it the duration of the flashing events? We still don't know. So we have a lot more that we need to learn about the squid before we're able to go down there and start talking with them. But I'm excited that we've gotten a first step towards this, and I think that with a little more data, maybe we'll be able to fulfill my dream, and what I hope is now your dream of being able to talk to Humboldt Squid. I talked really fast, so I'm sorry that was kind of short. But thank you.
We've got a lot of time for questions.
I was wondering, have you you thought, or is it possible to try this in a lab setup where you have more controls of them?
Yeah, so the problem with that is that no one has found a way to keep Humboldt squid alive in captivity. Because they are used to the open ocean and they do really large vertical and horizontal migrations just in the course of one day, that you put them in a tank, and no matter how large the tank, we find that they always are just running into the sides of the tank, and they end up just damaging themselves too much, and then they die. And they also get really stressed out, probably because it's just such a different environment from what they're used to.
I'm just curious a little bit more about how you captured that particular squid and put the...
Yeah, what we do is we catch the squid using what are called squid jigs, which the top part glows in the dark, and the squid are attracted to the light because, like I said, a lot of their prey actually produce light. And then underneath it, there are these rings of spikes that point up, and when the squid kind of grabs onto the light, it ends up getting its arms tangled on these spikes, and squid mostly, when they're trying to escape something, they swim backwards. And so they're just kind of stuck on these hooks, and then you have a line that you can just pull them up with. And then once we had them up, we actually just had them on the side of the boat. In the water, you had a diver in the water holding it while everybody else was kind of just getting the camera attached, and then the squid is just released.
Premature for Humboldt squid, but I'm wondering whether anybody has created like an artificial squid that they can control the light frequency and flashing and all that kind of thing, and try to stimulate responses.
Not that I'm aware of. So we've thought about that, but the problem is that since the chromatophores don't actually produce light, it's just a color issue. So I'm not an engineer. I don't know how you make something that you have to make something that changes color but doesn't produce light. And I don't know of anybody who's tried that. I'm sure some people have and just haven't published it. But I think that we need to probably just know a little bit more about it, about what we think the signal is before we try that, just because I right now can't think of any way of deploying something like that where the squid aren't going to know something's up. You just try to sort of make this fake squid and throw it in the water with them and have it be doing all these crazy flashing things. I really think that the squid would just attack it.
But in the history of animal behavior, people have used all kinds of models
Oh yeah.
to try to elicit responses.
Yeah, and I think that just the problem with this species is because they're such a voracious predator and because they're so cannibalistic that if they sense a weakness in another individual, their first instinct seems to be to attack it and kill it. So I think that if you threw a squid-like thing in there that's kind of doing some weird flashing behavior that they're not really sure what's going on, it might elicit an aggressive response.
Or you might find a flashing behavior that scares them.
Yeah, so I think it would be fun to try.
When you were gathering the videos, did you get enough usable video time where you could split it up into aggressive behavior, non-aggressive behavior, and the patterns that they...
Yeah, so it was difficult because it can sometimes be difficult to tell the difference between an aggressive behavior and a mating behavior in these squid. So you saw in one of the videos that I showed, they were doing sort of this arms-to-arms interaction. That's actually part of how they mate. We believe they mate, is the males will deposit their spermatophores around the mouth of the females. And there are these pores that the spermatophores will we think that they burrow into, and the female stores the sperm there. And we did capture a couple of what we are pretty sure were mating events because we could see spermatophores in the water. And it's hard to, except for the presence or absence of spermatophores, it's really hard to tell those events from just any other arm-to-arm display. They're really fast and really kind of harsh, so I don't know. I don't speak enough squid yet to be able to say this was aggressive and this was mating.
When you bring the squid up and you're preparing to put the camera on it, what kind of other biological data do you attempt to collect while you've got the squid up? Do you try and determine the sex of the squid or the age or anything like that to give you some more info about the interactions you're interested in?
Yeah, so the hard part about that is when it comes to Humboldt squid, really the only way that we can know anything about them is by dissecting them. So you can't tell the sex just from their external appearance. You can't tell their maturity based on their size because they can mature at a wide range of sizes. So really the only thing we can do is take a measure of mantle length of the body size and have that for our records. And generally the females tend to be a little bit bigger than the males, but that's really, we can only kind of just guess at it. So we're working on developing some techniques where maybe we can sex the squid in a non-invasive way to do these sorts of appointments, but we don't have anything right now. All right, one more question?
Just a thought, I don't know how ethical this would be, but one idea would be at the end of the video, just bring the squid out with the camera and you could get some data that way, but I don't know if that.
Yeah, I don't know how we would do that, because the idea is to not have them tethered at all. We want them to be swimming as freely and naturally as possible. So unless we can like have it deploy some massive flotation device that just whips the entire squid onto the surface, maybe we should work on
That's what I
that.
thought, but I don't know, I'll be all right.
Well, thank you, Hannah. That was